All right. Hey, good afternoon, everybody. Good evening, good morning, wherever you may be. Ponch Rivera here. I'm here with Denise Holt. Denise is the uh, podcast host of Spatial Web. Make sure I get this right. Spatial Web AI podcast. Did I get that right?
Correct. Yep.
What is the spatial web, and why the heck would you want to talk to me? That's what I'm curious about.
Well, okay. So the spatial web is it's basically the next evolution of our internet protocol. So, we are currently living in a world where we're interacting with websites, web pages. And yet all of these converging technologies are coming together that really require us to be able to have a network of spaces and all of the things within those spaces. So
Nope.
the Spatial Web Protocol of HSTP, Hyperspace Transaction Protocol, and the
Okay.
programming language for it, Hyperspace Modeling Language, gives us the framework to be able to move into this kind of digital twin computing environment where every person, place, or thing in any space, in any reality, is now locatable and identifiable. And the protocol allows for gatekeeping
Okay.
around each entity.
Right. So if we go back to early 1970s and DARPA coming up with what we now know as the internet, is that considered Web 1.0? Is that right, or is that where are we in the
Yeah, I
evolution on
believe
this?
so.
Okay,
Yeah.
so we have DARPA coming up with this idea back in 1972, or whenever it was in the 70s. We grew up with it. My generation, we see Web 2. We're moving towards Web 3.0, and is that spatial web, or am I
Yeah,
off
Web
on that?
3.0, spatial web, they're interchangeable, yes.
Okay. Okay. So that's pretty important, but that's an enabler for artificial intelligence, correct?
Yes, yes. So the magic of this
Mhm.
new network of everything is that it really gives us a foundation for an entirely new type of AI called active inference AI.
Okay. So active inference AI, I think a lot of people are familiar with Chat GPT-3 and GPT-4. And I believe those are called LLMs, which I'm going to try it. Large language models, right?
Yes,
Is that
yes,
correct? Okay.
yes.
So LLMs and active inference, artificial intelligence, night and day, correct?
Yes, night and day, two very different types of. So, and the difference can be, equated to, these LLMs, they're transformer models. It's machine learning AI. They're algorithms and they're
Mhm.
incredible tools, but they're limited in what they can and can't do. And they have no awareness, no understanding, no ability to gain any within
Yeah.
themselves. So they're like tools in a toolbox. Active inference is modeled after biological systems like our brain and the way our body works and the way nature works. So it's like a toolbox versus the human.
Right. So there's a connection, and that has to do with biological systems, complex adaptive systems, and why Denise is on the show today. And that is because active inference AI, I'm going to say this out loud and to the world right now, is OODA Loop AI. Right. So there's a difference. When a lot of people think about linear systems like Plan, Do, Check, Act, PDSA, nothing wrong with them. They're linear things. They're pretty cool. They work in a context. To me, that's an LLM approach. It's not a closed system necessarily, but it has a data source that it's learning from, and it's not an open data source. It's kind of a closed data source. It's limited, right? That's one way I think about it. And then active inference AI has sensory capability that looks outside and adapts. And I have a
Yes.
couple notes here, and I want to see if these make sense.
Okay.
Um, and you already said this, but LLMs do not actively interact with the external environment, correct?
Right.
They don't actively interact. And they don't take actions to reduce uncertainty or what John Boyd called mismatches. So if you familiar with the John Boyd's OODA loop in competition, one of the things we want to do is we want to create mismatches in the environment. to slow down, to defeat, to get ahead of, whatever you want to think of in competition, to get ahead of your enemy or your competitor, or get inside the thought process of your customer. So that's you need to take some type of actions to reduce uncertainty, to avoid things like being taken advantage of by a thief. That's what we're doing all the time in our brain. So that's a little bit more on active inference AI. Any other differences that you can think of, Denise,
Well, so
about LLMs and
yeah, these machine models. There's two different aspects to the way the AI works too. So these machine models, they require enormous amounts of data to be fed in to train the model, right? That's because they're pattern matching, pattern recognition machines.
Right.
I mean, that's all they do. So the more data you feed it, the more likely they are to be able to recognize the patterns and make make decisions based on what they recognize as familiar patterns that we already use and recognize.
Right.
So big data coming down. It's not a very scalable approach. Now, active inference can take any small amount of data and make it smart because
Okay.
it's instead of looking inward to the historical data that it was trained on, it's able to look outward to the data that is presenting itself at that moment, and it can update in real time. So it can take in data from sensors, from cameras, from the actual spatial web protocol itself, with the programmable context that is informing it of relationships between the data and between the entities that are within the spaces. So it can, and because of the gatekeeping aspect of the protocol itself, the same active inference AI can be applied to, proprietary data and keep it internal, or it can be applied to enormous amounts of, interlinked data throughout the planet. It has a lot of flexibility.
So what I'm hearing from you, and maybe I might be wrong on this, but an LLM requires, I'm going to say this, it requires more energy. And if you go back to biological systems and what I understand about the free energy principle and active inference, which we'll probably touch on here in a little bit, and a little bit about the brain weighs 2% of our body weight. It burns 20% of our energy. It's a highly, it's burning a lot of calories, right? So it has to find efficiencies. And if I remember correctly, active inference borrows from that type of thinking in the brain, that we have to find a way to reduce the energy spend on how we perceive the world. So I believe what's going to happen is, if we do shift from LLMs to this active inference, the energy required to do so is going to be lower, which allows novel things to happen with active inference, the same way that happens with our brain. And by the way, that's what the OODA Loop is about. I believe the OODA Loop actually captures active inference before active inference and FEP were a thing, and we could talk about that here a little bit. But I get that right? It's a lower energy cost to use active inference approaches.
Yeah. And, one other really important difference too is these machine models, because they are, neural nets that are just, they have all this input. They take in, they take input, they're comparing it to the training data and giving you an output, but all of that activity within the neural net is obscured. So you can't explain how it comes to its decision. You can't. They're not explainable. They're not even observable. And therefore they're not auditable either. So that's one of the biggest difference with active inference, because active inference, the entire action perception loop of how it is getting to its decision making, it's transparent, it's auditable, and it provides a situation where the AI itself can reflect on its own decision making process and report on it. So
it's kind of like a black box. You got this black box doing stuff and you have no idea what's going on the inside of it. This is very dangerous. And when we're coaching organizations about black box, not necessarily black box thinking, actually there is a connection there. When you go into black box thinking, you figure out what's actually going on the inside. And the black box thinking comes from the cockpit of a commercial aircraft, where you have the black box that tells you what happened in the aircraft. But you have to use that at some point in the future, usually in a accident report. But when we talk about black box thinking, or black boxes in an organization, they're usually just these things that magical things happen in and nobody knows why. That's very dangerous, right? And
Yeah.
from a lean perspective, that costs a lot of energy. And what we want to do is we want to know what happened, that explainability and accountability within that black box. And I believe if
Right.
active inference gives us that capability to learn from the AI, how did it come up with this decision? What was its process? Is that correct?
Yeah. And, and when you're thinking about the value of the two different types of AI, it's really important to think of our use cases for AI too, right? So if you take one of these LLMs, one of these transformer models, if you're just concerned with making things, write me a report, make me a picture or a video, or, like perform a task, create code, write me some code, they're good at that. They're amazing. They
Yeah.
save you a lot of time. It's wonderful. But when you have no way to know how it's achieving or it's arriving at its decision making, at
Mm-hmm.
its outcome, then it's impossible to use it for mission critical decisions like anything to do with medicine, or
Yeah.
how operating an airport, or anything where you have to be able to, number one, understand how it's getting to its decision so that if something goes wrong you can correct it,
Yeah.
but also so
This is awesome because this is what we actually coach organizations is we want to separate your outcomes from your decision making. And that means we want to look at how you interact as a team to see how that works. So we can repeat that over and over. And once you repeat it, you borrow it from somebody else, and you repeat it, you improve it over time, over and over again. So that's the parallels between what we're coaching in organizations and what I'm hearing from you on active inference and even LLMs is pretty powerful. Now, I got a quick story. Uh, as you know, we talked not too long ago. I'm in Colorado. My mother passed away. There's a lot of things that I think AI or active inference AI can do in future scenarios that are similar to my mom's. But for an LLM, I used ChatGPT 3 the other day to take my mother's obituary and some stuff from her life, and I had it write 4 different songs. George Strait song, Straight Outta Compton, and then something from Elvis, and then I can't remember the fourth off the top of my head. But it was such a novel thing that it captured my mom's life in song,
uh,
and everybody at the funeral was like, "How did you do this?" And so it was a very powerful way to kind of recognize my mom's life, but at the same time have some fun and so show people some new technology. But an LLM cannot have saved my mom's life. I guarantee you that because to me, it's looking backwards and not looking out, right? And we need
right.
capabilities that look out to bring disparate information together and get away from these siloed approaches. And by the way, that's what we're trying to do with organizations in the first place, is get them to break down or to work across their silos, because you can't break them down. Work across them so they can learn as an organism and create better outcomes. Is that what you see happening with active inference AI? Is creating that
Yeah. And
different connections?
yeah, and one of the things with marrying up the active inference AI with the spatial web protocol, is it's a framework of these nested spaces, right? So then you have the advantage to be using Markov blankets, and
Yeah.
it allows for this action perception loop between all things in real time. So it's really it's really interesting because when you think of the free energy principle, and obviously there's all possibilities for outcomes at all times. The way active inference works within the protocol and then all of the sensory input is it really works in a way to minimize all of the external noise and be able to actually focus on what's important, what actually relates to the task at hand or the desired outcome. And and you can get there, and then it's happening across a network simultaneously at the same time.
Yeah.
So it's scalable without the requirement of all of this extra energy that's really not needed. You know what I
Yeah.
mean?
Yeah.
Yeah.
Yeah. And I'm hearing some stuff that LLMs are hallucinating. There's a great story in the last couple of weeks from, I don't know if it's Time Magazine, but there's lawyers are using it to create to reduce their workload, but at the same time they're asking it to find cases, and these LLMs are actually creating new cases, which is not going to
Right.
stand up in court. So they're actually hallucinating, and we have a John Boyd bot right now that looks back at some of our data, and it hallucinates too. It makes crazy connections. You're like, that's not true. So LLMs, and this is my perception of LLMs right now. They're pretty cool. It's not the coolest thing out there on the block, but everybody's talking about it right now. That's what everybody wants in the LLM. Uh, my belief is, as people learn how we perceive the world, how our mind actually works, how our reality is a controlled hallucination, all these great things that are coming from mental health, psychedelic assisted therapy, from active inference, from Carl Friston, from Dr. Hippolito, you name it. There's all these amazing things are coming together. My belief is that I can show this in a short amount of time through going through John Boyd's OODA Loop. And we could talk about that down the road. So next question to you is, if my perception of the current reality is common, which is a lot of people are focused on LLMs, who in the world is actually looking at active inference AI? Are there any companies out there or anybody we should pay attention to?
Well, yeah. Okay. So, so Versus AI is a cognitive computing company. They basically, so let me back up for just a minute, just to give a little bit of background to the
Sure.
audience. So, back in, I don't know, probably 2016, 2017, the founders of Versus were seeing all of these converging technologies coming together, but there was no underlying framework for the interoperability between them. And they had a vision and an idea for what they wanted to do. So, but this framework had to be there. So that framework being the Spatial Web Protocol, this protocol that takes us, from websites and web pages into 3D spaces, and this digital twin capability. So they built the protocol, donated it to the public because nobody can own the internet, and then donated the protocol and the IP to the IEEE, which is course, the world's largest core standards body that has everything to do with, electronics and engineering, and is responsible for all of the, core standards around things like Wi-Fi and Bluetooth and even nuclear energy. And so that happened almost 3 years ago. So in the last 3 years, there have been core standards being built around this technology with, some of the biggest brains all over the globe. And at the same time now, Versus had the foundation to be able to build what they intended to build on top of it, which is, a COSM operating system, which enables these intelligent apps then to be built and utilized within the network, right? So it becomes this network of distributed intelligence. And so since then, they've been working with Fortune 500 companies. They've been working with governments all over the globe that are building smart cities. They've been involved for almost 3 years in a European drone project called Flying Forward 2020. And to work out to work out and to prove the concept of using the protocol and the active inference AI and being able to translate human laws, like all of the airspace laws and all of the different things, translate them so that the drones can understand them and act accordingly. So, that project has been met with huge success, and so what's happening later this year is all of this is now coming to the public because COSM, with this app store where anybody can build an intelligent app, is going to be released to the public so that, it has this public face. And along with that, the interface then for this new internet experience is called GIA, and that's general intelligent agent. It becomes every person's personal assistant to navigate, browse the web, but even more so, it literally can act on your behalf.
Yeah.
So there's a lot coming that, it's really interesting because, it's going to really change our lives and the way we kind of exist. It's going to bring all of these technologies, the interoperability between them, this augmented existence that we've all kind of envisioned, but the foundation really hasn't been there. It's all coming into fruition. So, things are going to look a lot different once we're living and working in that space.
What I find interesting is just in the last 24 hours, there's a new paper that came out. I think it's called Designing Explainable Artificial Intelligence with Active Inference, a framework for transparent introspection and decision making. And I look at the folks on there. I believe Gabriel Rene is the CEO of Versus. Is that correct?
Yeah.
Next to him is Carl Friston, Dr. Friston, fame of fMRI, and then active inference and the free energy principle. A lot of math involved in there. There's some other names I'm not too familiar with.
Scientist as well.
Yeah. Oh, he's a chief scientist for Mm-hmm. So there's a lot to unpack here. Just on the names on this paper, and there's for our listeners. Early on, we had Dr. Ines Hippolito on, who talked about active inference and cognitive science, neuroscience, some things like that. We even talked a little bit about psychedelic assisted therapy. But as I look at the names on here, these are the who's who in the zoo right now of not just artificial intelligence, but how the brain actually works, right?
Yeah.
And then going back to our show again, I had a quick conversation with Gabriel Rene not too long ago about the constructal law. He's familiar with that, which is from Adrian Bejan, law of physics, a law of flow systems, really. And then there's a lot of discussion now about complex adaptive systems theory, and one of our advisors, and to my company, and then to who was our first guest on our show was Dave Snowden, so complexity theory theorist and the Cynefin framework creator on our show. So what I'm getting at is we accidentally came to meeting Denise. This was all by no design, but I do want to get back to this paper here. So when I'm making these connections here about how are all these folks interrelated, they all have different disciplines, but at the end of the day, they're all coming together to solve some of these, they're not problems, but opportunities, right? So on this paper, you kind of pointed out some things on this paper already when we started. Explainable AI, that's what they're talking about in the paper.
And you
how do you
asked
provide human Yeah.
I'm sorry. I was going to say, you asked me who's paying attention, who's going to pay attention to this.
Yeah.
And this paper and another report that they announced that they're going to be releasing mid-month, that's, it's called The Road to Autonomy, A Path to Global AI Governance. So this paper talking about how active inference AI provides explainable AI, it solves the issues that we're having with trying to put governance around AI. So all of this is going to make the world pay attention.
Right. So what I like about this is human understandable explanations, right? So when you look at the free energy principle, I'm a human, and when I read it, it's just full of math, right? I'm just blown away. I'm like, I'm done. I can't read it. I like drawings. I like pictures. Unfortunately, John Boyd gave us the OODA Loop, but unfortunately, too many people think of it as just a simple decision-making process. Now, I'm going to share something with you I put into our bot earlier about the origins of the OODA Loop. And this is coming from a pretty big data source that is not open. It's from John Boyd's archives. And we just asked it, what informed the OODA Loop? And I think there's some interesting connections here. It comes from a variety of scientific disciplines, including physics, engineering, psychology, and biology. This is the first thing our bot put out. It didn't say it came from fighter aviation, right? We know this. We tell people that all the time. He drew on concepts such as thermodynamics, so the second law of thermodynamics, which is extremely important inside of the free energy principle and complex adaptive systems and so forth. Cybernetics. Cybernetics is absolutely critical to the free energy principle, game theory, and theories on decision-making and strategy. He also studied the behavior of fighter pilots in air combat. So my background in fighter aviation, many people make that association that it's all about fighter pilots going through OODA loops. No, the OODA loop again, this is Brian's view. When you put a Markov blanket on it, which we'll probably talk about down the road, and we have talked about in the past, you create the action perception loop, and you get to see what's actually happening on the inside of the Markov blanket with the sensory states and active states. There's also more behind this. John Boyd was influenced by a wide range of scientific disciplines, including mathematics. Norbert Wiener, who developed the field of cybernetics, we already talked about that, living organisms, machines, and complex adaptive systems thinking and systems thinking. All right, so there's a lot there. And this is why when we had Dr. Hippolito on, we are kind of like, hey, is this not the same thing? Are these things related? And the answer is they may be. There's no need to connect anything, by the way. But if we're going to explain how the brain works, how people perceive reality, and at the same time show them how active inference AI works, wouldn't it be easy just to show them the same thing? You know, and that's what we're trying to do here with one of the things we're trying to do here. Denise, any thoughts on that, or am I just talking out of turn here? Am I crazy?
Oh, no. It's interesting because when you reached out to me, I looked into the OODA Loop theory because you had said that the show focuses on that. And as soon as I saw it, I was like, oh, I know why he's reaching out to me.
Yeah.
Because they're very closely related. So yeah, I definitely see that connection.
Yeah, no, it's great. And I know, you and I looked at some slides not too long ago. We may be able to go into them here if you want to, but I just want to see if you have any questions about what we're doing with Boyd's OODA Loop, or any overlap that I'm missing between what you understand about the spatial web and what I understand about human performance, anything like that.
So I think that they both kind of come to the same, the same resolve in that it sharpens your perception to achieve a more accurate outcome, and it's a very similar action perception loop for that process. So yeah, I mean, I definitely see the relation.
Yeah. So spatial web, AI, and then what else are you associated with? You have any other connections, or you got the IEEE working group? Anything else?
Yeah, I'm a voting member on that IEEE working group.
Okay.
So I've been, kind of watching and participating with these core standards being developed. And yeah, I mean, that in itself is an interesting process. But, one thing I will say is that, all of the people that are involved in this process, the level of integrity and the level of just awareness and even the introspection, right? Just in understanding that this is a monumental task, and it's going to have an effect on the future generations, in a tremendous way. So, it's I don't know. In a lot of ways, I feel really grateful to be a part of it. And, but I've felt like that about kind of technology for quite some time. I feel lucky to be alive right now. We're in the greatest time of technological discovery, to be able to be a witness to all of these things, happening and evolving. I'm a tech geek girl at heart, so it's fun to me.
Awesome. Hey, so I want to invite you to continue the conversation, but I want to transition over to some slides, which means our listeners may not get the full experience if they're listening to this. We'll try to do our best to walk through these slides. We'll also put this on our YouTube channel, and you can definitely have a copy of this as well. But before we jump into that, how close are we to active inference AI becoming as prominent as LLMs, ChatGPT-3, ChatGPT-4? Are we 5 years away, 10 years away, a week away? Where are we?
No. So, as I mentioned earlier, Versus AI is launching their Cosm operating system with App Store on top of it, and the Cosm operating system will have GIA, which is an intelligent agent interface for the public, right? So that is ushering in the active inference AI in a tangible way for us as humans to now interact with it. As far as the public, being able to interact with it. So anybody can build one of these intelligent agents. These intelligent agents are going to be the difference with these apps versus like building an app in like the App Store or Play, Google Play, is that you're just building siloed software, right? These are intelligent agents that are aware of each other and aware of everything within the network. So they will be able to act accordingly. And so, that you'll see this active inference process playing out. And as it interacts and acts within the network, and it'll improve its learning ability, it'll improve its awareness, and it'll grow from there. So it's been described to me that when Versus first launches this the operating system, and people start building the apps, it's not going to be totally apparent of the differences in their capabilities between these machine models and between the active inference. But it's been described to me that the difference is if you take like a toddler and a chimpanzee, they seem like they have about the same amount of mental capabilities, right? But the difference is that toddler is going to grow into an adult, whereas the chimpanzee stays the same. So we'll start to see it evolve over the next couple of years, but the access is coming very soon.
Okay, great. No, this is fascinating. So what I want to do next with you, and again, this is all voluntary. I want to dive into some slides, and I want to invite our guests to listen in and then potentially shift over to a YouTube channel to watch this. And we'll give links for that in the future. But what we're going to do is we're going to go back and kind of recap what we talked about, but put some animations to this so people can understand it. And we're also going to make some connections to action perception loops. We'll draw out the free energy principle, and then I'll go through Markov. We'll go through Markov blankets, and I'll make a connection to the OODA loop, and then we'll show you what it looks like through the lens of the OODA loop to really see what active inference could mean without the math. No math involved today. So math some other time, but we can always plug that in. Is that something you want to do?
Absolutely. Yes.
Okay. I'm going to try to share a screen here, which could be kind of fun. I'm going to go to a window. I'm going to go here, and here we go. And it's coming up. We'll mark this. It's going to take a moment to come up for whatever reason.
Cool.
Transition over. Okay, we'll start there. It should transition over to the full screen here in a second, but we're going to talk about the action perception loop. Now, let me make sure this comes out correctly. It's always something. It's one of the limitations of these new technologies is they don't like to play with each other. And there we go. Let me play this first, and we'll drive it that way.
This is so fun.
This is fun. All right. Waiting for the computer to come up. There we go. Okay. Basic thing, action perception loop, right?
Just the whole conversation.
All right. So our guests heard us talk about action perception. This is the basic foundation of how we interact with our outside world. The idea is that we observe things. They come into our sensory signals, or excuse me, our sensory organs. We have 5. We may have more. I'm not going to argue if we have 5 or 20. It just depends on your perspective of the world right now. I do believe we have more than 5, but that's another story. And then we emit some type of action to change the external world. So this is the basic foundation of it. Some of the notes you see up there, Denise, are from different books that I have around here. One is from Bobby Azarian. We got stuff from David, I forgot the name already. I apologize. But anyway, I'm borrowing from different folks on here. Okay, so what's on here? We have living organisms constantly engage in reciprocal interactions with their environments. That's the truth. I mean, that's, again, science-based, right? We emit actions that change the environment, and we receive sensory observations from it. From physics, we know that observations are interactions with the outside world. Observations are interactions, right? So we're interacting in some way. That's one way to think about it. And there's other things on here. Any interaction between two physical objects is an interaction or observation. Interaction permits vitality and growth, while isolation leads to decay and disintegration. That's from John Boyd, right? So we have to interact with our outside environment. And the animation I have here is pretty simple. We have our sensory signals, our eyes, ears, our sensory organs, eyes, ears, nose, mouth, skin, interoceptive capabilities, picking up some type of vibration, photons, whatever it may be from the external world, right? And then we emit some action to change that external world. It could be changing, closing an eye. It could be tilting our head. It could be actively listening to somebody. It could be swatting a fly. It could be whatever, right? It could be putting information on the internet. Those are all actions. So that's the action perception loop that Denise and I were talking about previously. So let's go ahead and do something to this. We're going to label the observations with an O and the action with an A. And this is going to lead to something very important. This leads to the free energy principle. So observations are represented by a sphere. All right. I'm making it a sphere on purpose. And for those of you who follow or understand John Boyd's OODA Loop, the sphere is observations. And then for action, we're making it into a box, a 3D box, and that's action. That's the observed act loop, if you will. So that's what this animation shows here, is we're going to take these sensory signals and we're going to go ahead and put observation and action in there. And then eventually we're going to add a boundary in a moment, which is going to be absolutely critical, not only for how we perceive the world, but for active inference AI. Okay. Before we do that, just touch on the second law of thermodynamics is very important. We're not going to spend a lot of time on this. Going back to your story about cooking and free energy, useful energy is called free energy. There's a lot of energy in the atmosphere or in the environment. If it's useful to us, it's free energy. If it's not useful to us, it's just waste, right? So it kind of goes back to your analogy there. We must continually extract that free energy. Otherwise, we die. So one thing about the second law of thermodynamics, when it comes to biological systems, we don't necessarily abide by it, right? We're not always going towards a state of higher entropy, right? Or equilibrium. We don't want to go to equilibrium. We want to be far from equilibrium with our external environment. But there's a lot of second law of thermodynamics involved with FEP. I just want to touch on that here because we're about to talk about the real fun stuff in a moment. And that's the Markov blanket. Could you walk us through your basic understanding of a Markov blanket, Denise?
Yeah. So, I'll do it in regard to how the active inference works within the spatial web too. So, when you have these nested spaces, these nested entities, and that could be an object inside of a house, inside of a city, inside of a country, or a restaurant inside of a skyscraper building, inside of a city, inside, there's nested entities, right? So the way the spatial web is structured is in a holonic structure. And, holonic architecture is basically where, something can be a whole in and of itself and be inside of another whole that is a whole outside of it, right? And this nested kind of structure. And we're like that in our bodies, each cell is a whole cell, but, the heart is a whole heart and it's made up of these individual whole cells. And then your body contains the heart, contains the cells, but each one is a whole, nested inside of the other. And so the Markov blanket becomes a boundary around each nested entity, and it determines, it basically separates the internal state from the external state, in the sense of allowing the larger entity to govern the smaller entity, but allowing the inside entity to still govern itself. So that's my understanding.
So this is critical, because when we have multiple people looking at something, we want to be able to define that boundary to say what's on the inside, what's on the outside. And your point about the heart or a cell, even the mind and the body, and we can put a blanket around that, but we have to have a common understanding of what's on the inside and what's on the outside. And once we have that common understanding, we can now talk about how this works. I believe that's a common thing with the second law, thermodynamics as well, the constructal law, we create a boundary. And the moment you put a input and an output on it, you just created a flow system, right? This is really cool. So now we get into constructal law, we get into complex adaptive systems, biological systems, all that. But we define that as an observer where that boundary is. And I may be wrong on that, but I think Adrian Bejan said we'd have to define that system or that boundary, and that's that Markov blanket, which is, it's not a real blanket, by the way. I'm not sure why they call it a blanket, but it's a boundary. All right, that's how I kind of look at it.
Right.
So yeah, so the idea here that we have on the slides is you have to have the precondition for any adaptive system is it must enjoy some type of separation from the external environment, just like our bodies do, right? So we have to have some permeable separation from the external environment. It's a statistical boundary, I believe it is. Math involved in this. I'm not going to go through the math because I'll scare everybody. I don't do that. But there's something very important about having the boundary here, and I'm going to draw something while we've got this. Hopefully it works on here. And that is the sensory states, which are listed as an O. Remember, observation. These are called sensory states in the free energy principle or active inference. Observations. And then below that, we have another sensory state, which is called our active states. So sensory states in the green, active states in the red. And again, sensory states are listed with an O as a sphere, the way I have it drawn, and a box are the active states listed or with a text of a small a on it, right? So those are part of the blanket. They're the parts that interact with the external world, which is very important here. So I'm not sure if I have an animation on this or not. But the key point here is your sensory states, the observations or O, and the active states, the A, are part of the blanket. And in this blanket, by the way, and I don't want to go through this today, but it's an entropic blanket that we use. We borrow it from Rebus and the entropic brain hypothesis from Robin Carhart Harris, who borrowed a lot of ideas from Carl Friston. So for those listeners that are out there trying to figure out what we're talking about, there's plenty more depth we can go into. We're not going to dive into that today, but there is a reason why it's an entropic boundary the way we have it drawn. So here we go. A quick animation there. What we're doing here is we're starting with the sensory states and active states, and we're putting a boundary, in this case, around the mind and the head, but it's not the brain that we're targeting here. It's a boundary. You can put the boundary around your body. You can put the boundary around your head and in a tablet or a computer or a notebook. It doesn't matter. It's just a boundary, right? We got to define that boundary. So that's what we're animating there. Denise, any questions on that? Thoughts, concerns, questions?
No, go right ahead. Keep going.
Is this fun? I mean, I wanted to do this with you because I'm like, hey,
a great time.
No, this is fun for me because we get to have a conversation and go, where are we wrong on this? What are we messing up? Okay, let's see what's next on here. I'm going to just pause for a second and see what we can dive into next. I don't want to dive into the.
So I do have just I guess an observation or a question, or maybe just a kind of the way my brain works. So when I'm looking at that, and you're talking about the Markov blanket, and the observation and the action being, at the boundary point, right?
Yeah.
So basically, I mean, that's saying that we can choose to observe or not observe, or take in an observation or not, right? Or we can actually block off certain sensory observations. And what came to mind with me is if you put a blindfold on, right? You're not taking in any sight. And what that's going to do is that's going to increase the likelihood for, uncertainty of your environment, uncertainty, it increases the ability to be surprised by things because now you've blocked off the ability to see that.
Yeah, and I think there's a great example of that is when you go into a dark room, I think there's a lot of free energy in there until you turn on the lights, right? So I think that's what you're kind of getting at too. And I may be wrong on that. Yeah. No, let's build. We're going to build on that. So we're going to come back to that. What are the couple things we can do when it comes to changing the environment or adapting our internal model? So I'm going to continue this. Hopefully this works out. Okay, back to the slides here. There we go. Okay. So now we're going to dive into the free energy principle schematic. And this is a basic schematic that you'll find online now. It's been modified over the years. I think I have it captured correctly now. I may be off on a few things, and that's okay. But at the end of the day, what we're going to see is we're going to have the external states, the internal states, and then the two things we talked about earlier being the active states and the sensory states. So we have a boundary around a brain and a head, if you will, where we can see the brain, which we're going to call just the internal states, which is everything inside the blanket. It doesn't mean the brain is an internal state. It means everything inside of the Markov blanket is an internal state. We have the active states and sensory states that are part of the blanket. And then we have this thing on the outside, which we call the external world, which could be a social system, physical system, a culture, whatever it may be. It's something external to the blanket, right? All right. So this is kind of interesting. And Denise, I'm not sure how. And by the way, I'm still a student of this. I don't think anybody is smart as the people that came up with this, but we're learning. This is interesting.
Yeah, I'm definitely still learning.
Yeah. So the external states contain hidden causes, right? And for those of you that have read Anil Seth's Being You, and try to, he talks about this and tries to break it down. It does a great job of breaking this down. There are causes in the external world that our sensory organs pick up. The causes that are happening out there are what we pick up through our sensory organs, right? Or our sensory systems, which could be sensory capabilities that we use in artificial intelligence too. So those are hidden causes that are out here. What else can we pull out of this right now before we animate this? There's a couple things that may not mean to a lot of folks, but internal states cannot directly change external states, but can do so vicariously by changing active states. And again, we'll have these slides available for folks. External states cannot directly change the internal states, but can do so indirectly by changing sensory states. A lot of words there. We'll animate this. I'll take Denise through this real fast, and we'll explain how maybe a what do you call it? An illusion can help us understand this in a moment.
Okay.
And I think this is where we want to get back to where we started, which is organisms follow a unique imperative. They want to minimize surprise of their sensory observations, minimize that uncertainty, minimize those mismatches, right? That's what we talked about in the first half of this. And I think that's what's going on when we talked about the difference between an LLM and a active inference AI is LLMs cannot do this, right? They cannot reduce or minimize the uncertainty or surprise coming into their sensory systems. This is the big difference. Okay. Any thoughts, questions, concerns there? This is fun, by the way. I'm having a blast.
Yeah, no, I'm having a blast. So that whole minimizing the uncertainty, gives us a sense of temporary control over, narrowing down the options to get to that end goal, correct?
I said yes. I'm sorry. I was having a quick drink there.
Oh,
yes,
okay.
Absolutely. And we'll dive into that again. This is really fun. Okay. So maybe there's an animation here. I can't remember. There we go. Quick animation, external, internal states. There's our observations going into our internal states. Here comes an active state. And now we're emitting some type of action on the external environment. We have not done anything to the action perception loop. We just defined a few more things within it. Foundationally, we put the sensory and active states on a blanket within a boundary. And we put it around, in this case, the head of a human or a biological system with space on the left or right side of it. Okay, let's go deeper. And let's see. Let's talk about this next. This will be kind of fun. This is let's come back to the monkeys. You're bringing up some chimpanzees. I don't believe these are chimpanzees, but we'll take a look at this again. All right. Before we dive into what I call the entropic OODA loop, I want to go back to surprise, active inference, and free energy here. So surprise, how much an agent's current sensory observations differ from its preferred sensory observations, desired minus sense states, right? What do we internally desire and what are our sensory organs sensing? The difference between them is surprise or free energy or uncertainty, or from John Boyd's world, mismatches, right? This is absolutely critical. And this goes back to the blindfold that Denise brought up earlier. And that is, you minimizing surprise is not something that can be done passively. It has to be done actively. And this is what active inference AI does, right? And this is the big difference between the LLMs and active inference AI. And there's more on here. I'll just read these off real fast. Agents must adaptively control their action perception loops. Remember, we haven't changed the action perception loop. We just added a few things to it to understand what's on the inside and what's on the outside. Surprise minimization permits living organisms to temporarily resist the second law of thermodynamics. Why is that temporarily? Well, all organisms die for the most part. I'm not sure if that's 100% true. But what we want to do is we don't want to be in equilibrium with our environment. If we are, you're 6 feet under, it's not a good thing. It could be a good thing. Living organisms cannot directly minimize the surprise. They can minimize a proxy called variational free energy. And I believe free energy is properly called variational free energy, if I'm correct on that. And then we act to minimize expected free energy, reduce expected surprise, or more simply put, resolve uncertainty. These are all pretty cool things, right? So what? Who cares about all this? And this is why we teach the OODA Loop. If you don't understand this, if you can't understand this, if you don't spend any time understanding this, people are going to take advantage of you. You're going to lose. You're not going to understand how to win in sports. You're not going to understand how to win in organizations. You're going to buy things that cost energy and time that do not work. If Denise is right, and I believe she is, and Carl Friston and Gabriel Rene are right, what's coming with active inference AI is going to reduce the energy cost for so many things. And there could be good or bad out of it. I'm not sure. But for the most part, what I understand is there's a lot of upside good on this. And Denise, are there a lot of people talking about the downside to active inference AI right now? Like some of the bad things that could happen? No?
No, I mean, it's interesting because like Dan Mapes, he's one of the co-founders of Versus, and he describes active inference AI within the spatial web network as a nervous system for the planet. It's going to give us so much ability to actually optimize all of these operations and all of these the problems that we face, optimize solutions for them, and the AI itself is going to be able to have this self-organization to maintain systems and to detect issues and correct them as it goes in real time. So it's going to give us so much capability to resolve a lot of the issues that we have that we really couldn't do otherwise. In the same way that these LLMs are so powerful for us to be able to save time and be efficient and in our tasks and our creativity, this is going to do it on an operational level.
So when you think about what humans are about, and this is my belief and maybe my reality, that is we explore. We are here to go further beyond maybe our own atmosphere, or our own universe, if you want to put it that way. We have buddies that are, one of our friends is going to lead the mission, the Artemis mission to the moon. All right. So flew with him years ago. Not something I want to do, but that's what he wants to do, is lead these missions, right?
How cool.
But what I'm getting at is we're explorers. We have to expand our knowledge. And I believe what we're seeing here is if we understand not just active inference AI, but what John Boyd gave us, what people are talking about, if we can simplify them and help people understand them more, we can, I'm going to use a term here, Yucatan, or spread the knowledge of what's coming next, and we can leverage it together and be a pretty amazing society. Let me connect one more thing here. Competition's one thing, conflict's one thing as well. At the end of the day, we understand from conflict that it ends up being collaboration, right? Collaboration's more important. And that's what I believe is going to happen here is with a solid understanding of how things work, we're going to collaborate more as a global society, and who knows what the limits are. Yeah. And that's why this is so exciting. I'm going to go build more slides here. We talked about that. Okay, so let's talk about the evolution of the OODA Loop in AI. And I'm just going to pause there while I get the slide sorted out here. But I want to take you through the process a little bit. And I'm going to do that with, let's do this. Yeah. This is Adelson's checkerboard. I'm going to share the slide with you here on screen. Many people have seen this from either David Eagleman or his books, or Anil Seth, or if you've ever been with me in a class, I do this all the time. This is pretty basic, right? The question is, when you look at these two squares, and I have, for those of you that are listening to the podcast, I have a checkerboard with a ball that's casting a shadow upon a couple of square, or one square, and the other square is not covered. They're listed as A and B. The question you ask is which square is darker. And Denise, it doesn't matter if you get it right or wrong. Everybody usually gets this right.
The crazy thing is, I know what this is getting to because I've seen it. It's like, where you have the split square, but it's the surrounding colors that make your perception off. But they're the same color.
Yeah, they're the same color, and that's it. So you ask this question, and it's which square is darker? And generally, I've never had an audience that they always go, that's a darker square, right? Which I just highlighted.
It appears so.
It appears so, right? So what I did is I just matched some colors here. I'm going to slide them over. And what we see here is that the square that's underneath the shadow of the ball, in this case, is actually the same color as the square that's outside the shadow. And going back to Denise's point,
it's insane.
even though she knows this, she's seen this before. Even though you know this, your mind still plays the same trick on you. And this has
my mind is still
right. It doesn't change. And the reason for that is anything inside of a shadow that casts a shadow appears to be darker. So we compensate for that, right? So we know that that's active inference. That's our brain working. We're going to talk about that here. And this is a great way to explain to folks what active inference is really about. So that's Adelson's checkerboard. Okay, so let me connect this back to John Boyd's OODA Loop. And I'm going to draw a few things out here as we go. Here we have a Markov blank. It's an entropic, it's an entropic boundary. And with it, we have our sensory states and our active states. And we have this little thing in the middle, which is called orientation. That orientation you can think of as an internal model of the external world, right? Okay. So I think you used a phrase earlier that digital twin, right? So I don't know if this is accurate or not, but sometimes we want a digital twin to understand what's going on in the real environment. I'm not saying you can think of it like that, but think of this as your internal map of the external world. We call it orientation. Right. There's a lot of cool things within it. We're not going to dive into those today. You can see our sensory, I guess not signals yet, but they're the photons, the molecules, the sound waves, the vibrations of the world that are hitting our sensory organs. In our case, our biological systems. For snakes, they're going to have infrared capability. For bats, echolocation, things like that. So every type of animal has a different type of capability. Humans have great eyesight for the most part. Our hearing's bad. At least that's what my wife tells me. And then sense of smell is not as good as a sense of smell of a dog. Anyway, so we're going to take you through this real fast using the Adelson's checkerboard analogy in a second. And hopefully I have the correct animations for this. All right. So let's see how this one goes. There's our animation. We got our sensory signals coming in to our sensory organs. The photons hitting our sensory organs, the vibrations hitting our organs there, and that's on the left side. And we're just going to transition this into the photons hitting our eyes, right? And that's what you see on the left side of the screen. You got a globe, you got these things hitting the O or observation portion of the OODA loop. And what happens next is pretty cool. There's our head, the connection to the eyes, if you will. This here is what are known as sensory signals. Sensory signals are a currency within the body that it doesn't matter where they come from. Our brain interprets them based off of previous experience. So I believe the signals from our eyes are pretty much the same thing from our ears, or they are from our skin and all that. They're sensory signals. It's the currency that is needed in our body, right? And currency being used from the concept of flow and flow systems. Okay, so we get these. It goes through some calculation, a generative process. And this is what's really cool about this. At some point, we make a decision or a prediction or a hypothesis about the causes. Remember what I said about the causes that are coming from the external world? We make a prediction of them.
Yes.
And this is this loop right here. So in this loop, and I'm not sure I can do it right here. Yeah, this goes around and around and around. And this is known as prediction error minimization, right? The difference between our sense, what's coming in from the outside world and what we expect to see. And going back to Adelson's checkerboard, it's the same thing. We have a prior expectation of what is expected, what we expect to see, and that's why we can't see the difference in colors in the Adelson's checkerboard, or we see them as two different colors. Excuse me. But that goes through a process, and this is predictive processing. It's one portion of it, right? So Denise, is this striking a chord with you? Is this kind of fun?
Yeah, absolutely. Yeah.
All right. By the way,
and I am.
What's that?
And I said, and I am having fun.
Those are fun. So I am showing you the OODA loop without talking about the OODA loop. This is really fun. So we'll continue building this out. So as those signals go around, actually I can do this. Something else happens here. Something has to go to active states. In our active state, in this case, let's use Adelson's checkerboard as an example. In this case, which is this line right here, this is a counterfactual, a what if scenario. This goes back to Denise's example of kind of thinking through what I need to do next, not actually acting on the external environment, but maybe if I tilt my head, close my eyes, use another sensory capability, maybe if I pay attention more, that's a what if scenario using Adelson's checkerboard. Like, just squinting. What if I squint? What if I turn my head? Not turning my head, but what if I do this? That's going on inside your brain. And I believe these are called conditional predictions, what if scenarios. If you scale this, and going back to Denise's concept of scaling or nested loops or whatever, if you scale this to a team, this is planning. This is a planning process. You're going to plan on what you're going to do to the external environment. Very, very powerful. So active inference is predictive processing plus a counterfactual. Well, wait, there's more, right? I hope I can do this more. Okay, ready for the more part? There's this piece here, which is going to be hard to see on here. There's the actual piece where we turn our head, pay more attention, and that's the loop that's coming from the outside of the the active state, the box on the right, and it's going to the outside world, and it's interacting with that. And it changes the sensory capabilities. We're doing something to the environment, which is changing how our sensory organs pick up things, right? I don't know if I did a good explanation on that, but that is basically what active inference does. But wait, there's more. Let me try to grab this slide here. At some point, we have to have some type of perception of reality, right? And that's what this loop does here. Here's the famous reality is a controlled hallucination loop that Dr. Seth talks about, David Eagleman talks about, a lot of neuroscientists talk about. You have to have some type of construction of reality, and that is top-down, inside-out. That's top-down, inside-out construction of our external world, and that is perception. Right? Up here is our perception. And over time, it gets better and better.
So
and
it's interesting.
Yeah.
Yeah. So I was going to say, what's interesting is I believe that would be the Spatial Web Protocol itself, as far as what that does for active inference, because it gives the world model. It provides an understanding of the way the world works, in that all of the context baked into, each thing, and then the relationships between the things, and, everything from identity to location to activity to, even things like, temperature and pressure and all of these things. It provides that understanding of reality. And that's why active inference is so different than these other, like machine models, because they have none of that. They have no ability to
Right.
have that. There's nothing for them to measure the world
And they're
around
not
them.
updating this by themselves. And that's what the OODA loop is about, is you got to update this thing called orientation, or what is known as the internal map. And I want to point out something else. This is
Mm-hmm.
kind of cool. Going to your point, this perception of the external world or reality is our mental models, their schemas, their repertoire, they're things that are embedded in there that we want to update as well. Because if we don't see the world, remember, we all see reality different. We need to update that thing.
Yeah.
Uh, this is also known as the default mode network of the brain, right? This is really cool. Your ego is here. And when you're stuck, when you're in a stuck state, or you're going through trauma, which we'll talk more about in later episodes with some trauma specialists, we need to suppress this thing. You need to suppress this to get down to these states down here to change your model of the world. It's absolutely mind blowing the way this works. So that's pretty wicked. So there's a connection back to rebus and entropic brain hypothesis through Carhart Harris and the work that Anil Seth did, baked in right here, as well as everything below here. You had something to say?
Interesting.
It's pretty cool. And there's one last piece.
I just said interesting.
Yeah.
I'm like, I want to hear more.
All right. And then the last piece here is this one, right? And this one is another implicit guidance and control aspect of the OODA loop. That's the piece I just drew up here. This is you can call it the autonomic response. I tell my kids, when you learn how to play basketball or dribble, you don't want to be down here trying to figure out how to dribble. Your body needs to know how to do this, right? That's our response to Adelson checkerboard was, hey, Brian, that's the same color, right? Even though we know they look different, even though we know they're the same color. That's our autonomic response. We can get into proprioception and interoceptive capabilities and nested OODA loops and things like that. But this is John Boyd's OODA loop in a nutshell, without talking about it. It's observe on the left, orient, decide, and act, right? Orientation, you're going to love this.
Right.
Orientation determines how we make sense of the world, decide in it, and act in it. And that is why active inference and the OODA loop need to be brought together. And there's so much more to dive into, Denise. I just wanted to share this with you because I've been dying to get this out there. But it needs to be done with somebody who is, one, not familiar, and two, is very familiar with what's happening with artificial intelligence. So I'm going to stop share there. And if I can figure out how to do that. There we go. That's that. Now I want to dive deeper into this in the future with you, if we can, Denise, and make some more connections as we go.
Sure.
But thoughts, questions, concerns?
Oh no, I just, I love seeing all of that laid out because, it gives me a deeper understanding too of how, because I see the mechanics within the active inference and, the free energy principle, and then how it becomes this, this AI, how it interacts within the Spatial Web Protocol, and all of that together lays this foundation for distributed network of intelligence, that can update in real time and everything else. And it's really interesting to see you lay it out like that, because then you see like where the sense making comes in and where all these other aspects of it. So it almost gives me, it's almost like it's giving me a bigger pattern to look at that is present in the other, but it's breaking it down even further,
we talk about distributed leadership quite a bit, and there's a connection there. So we're talking about human performance in organizations, creating agility, innovation, resilience, safety, employee engagement, whatever, psychological safety. You go into so much more. If you understand these basic ideas, and this is where I want to go with all this, is if I can explain to your leadership team in a matter of minutes or 20, 30 minutes how you perceive reality and how that connects to active inference AI, we're going to be able to create, I'll call them protocols or behaviors or interactions, the way we're going to work with AI in the future, right? And this is absolutely critical as we transition. I don't know if it's a transition or a phase transition, but as this new reality emerges all around us, you either learn this or you get left behind, right? There's You interact with your external environment, or you go to your dark room or your oxbow lake and hide in there, and let's see what happens. I will tell you what, I'd much rather take
Yeah.
people through this to show them what's possible. And if I'm wrong, I'm fine. I'm fine with being wrong.
Well, it gives you an understanding of the optimization process,
Yeah.
that goes on within each point of decision making within your mind, and
Mm-hmm.
if you understand how that works, then you can better optimize your outcomes. You can be more aware. You can
Yeah.
have more self-awareness to where you can really put it into action more, rather than kind of giving into distractions and irrelevant things. You'll understand better focus. To me, that's what this whole process really kind of comes down to is, it's like an explainability to
Yeah.
focus and action.
Yeah. I love it. So, hey, I want to thank you for being on the show today. This is really, it's just a good conversation to kind of make sure I'm bouncing some ideas off you, and we're talking about what's possible. I think I want to have you back on the show in the future to kind of dive deeper into where we are with active inference AI, and anything we can do to help you in getting the word out there. And as you know, our audience is it's pretty broad. A lot of folks will come on and go, "Why am I learning about psychedelics, or why am I learning about leadership and mission command and all these other things?" I'm like, well, because it's part of the OODA loop. You got to understand how these things work. But it's not easy to
Yeah.
do, right? So yeah, if there's anything we could do for you on Spatial Web, or with your clients and guests or whatever, or listeners, let us know.
Thank you so much. And thank you so much for having me today, Brian. This has been a blast, and, I'd be happy to, support you guys in any way I can too. So
Awesome.
thank you so much.
Oh, hey, before I forget, our listeners can find you on Spatial Web AI podcast, correct?
Yeah, so I'm on YouTube. It's also on Spotify, Apple, anywhere else. I also have a blog, and it's under my name, DeniseHolt.us. And I do a ton of writing on the spatial web and the active inference AI and kind of what's coming. And so my blog's a great resource to kind of point to all of the external stuff too. So
Okay, awesome.
And I'm Denise Holt _ on Twitter. So
Perfect. All right. And we look forward to those blogs. I read the one on LLMs, and you got ChatGPT-4. Is that right? Right, the difference between an LLM. Yeah, it's pretty cool. So practice what you preach, right? Figure out what the system knows about itself. Awesome. Well, I appreciate your time
Thank you
today.
so much. All right. Take care.